Welcome back, Algebra 1 folks. So in this video here, we're going to take a look at simplifying exponential expressions. So we'll start off with this one example here, x y to the 8th divided by y squared. And then we'll go on to two more examples after that. Now these problems are actually, in my opinion, kind of fun because I like crossing things out. And that's what you're going to do a lot of in these types of problems. Now it looks kind of funky, but if we just remember what exponents are and what they do, and we also remember how to deal with fractions, they're actually really not that bad. So I'm just going to start off rewriting the problem here. The problem we want to simplify, or the expression we want to simplify, is x times y to the 8th divided by y squared there. Now remember that all an exponent does is it takes whatever it's being applied to and is multiplied over and over and over again. So really, this I can rewrite as x times y, and there would be 8 of these. Right, did I count those right? 1, 2, 3, 4, 5, 6, 7. I think I'm missing 1. That's 8 y's right there. Right. The last thing here on the bottom, in our denominator, we have 2 y's. Y times y, or y squared. Now the cool thing about these, let's not forget that I'm being multiplied. Of course, you don't need to put these multiplication dots there every single time, but just for right now, I'm just going to leave them there to simplify them. The reason this is helpful now is that if you remember how fractions are multiplied, I can actually rewrite this big fraction like so. So right now, I can kind of group up the x and anything on the denominator that's also x related. Now, there are no x's in the denominator, but I can write in there that invisible 1 because 1 times y squared is just y squared again. So if I group those together, I can really think of this as, x divided by 1, and that's just that first part, times, now let's see, what's left over here? Well, I'm going to group them like so right here in this red box, 2 y's on top and 2 y's on the bottom. And the reason I'm doing this, y times y, or y times y. Actually, since we know what the exponents do, I'm just going to simplify this to save myself some time as y squared divided by y squared. And then what's left over, if I think about what I did with the x's to start, I also have 6 y's on top now divided by another 1 right there. And I can rewrite this now as y to the 6th divided by 1. Now, if we think about how we multiply fractions, if I take these 3 pieces right here in blue, 1, 2, 3, if I multiply them together, I should get back to this, right? So if you're not convinced, take a second and convince yourself that when I multiply x over 1 times y squared over y squared times y to the 6th divided by 1, I will get back to x y to the 8th divided by y squared. There's a reason this is helpful because, well, first off, the x over 1 and the y to the 6th divided by 1 are just what they are. Any number divided by 1 is just itself. And so there's nothing too interesting there. That's just x, and that's just y to the 6th. But what happens here when we have our y squared divided by y squared? 99% of the time, you take any number divided by itself, it's just going to be 1. Example, 2 divided by 2 equals 1. I don't know, 5 over 5 equals 1. Heck, even negative 3 over negative 3 is equal to 1. Right? And so y squared over y squared, you might have heard this term before where you're forming a giant 1. That just becomes a 1. And when all is said and done, you're just left over with cleaning up these steps. So x times 1 is just x, and times y to the 6th. We can't do anything else with simplifying this problem, so it's just x times y to the 6th, and that's our final simplified form of this expression. All right, so let's take a look then at these two other examples. So the two that we're going to take a look at are 6x, let me switch that down, 6x cubed times y divided by 2y, and the second one, 5x to the 50th divided by 10x to the 15th. So take a second and pause the video here and try these two problems on your own before we continue. Okie dokie, so I'm going to assume that you worked on those problems, and let's take a look at this first one here. So I have 6x cubed y divided by 2y. And just like this first one that we did right here on the left, I'm going to start off by splitting it up into kind of the pieces that match on the top and the bottom. So let's see. Well, I know, and I'm going to use my different colors here. Actually, let me give us some more space. So 2 times y. Okay, so if I group them up together, I have a y on the top and a y on the bottom. So that part is going to be y over y. I also have on the left here 6 over 2. I'm taking those constants or those coefficients and grouping them together. So I have 6 over 2. And the last part, just like in that previous problem, there are no x factors in the denominator. And so I'm just going to put an invisible 1 like as a placeholder. And so, oops, that's going to go right there as x cubed over 1. If I group these together now and simplify each individual piece, then we'll have our final answer. So y over y, again, a number divided by itself, is just 1. X cubed divided by 1, well, that's just going to be x cubed. Oops, x cubed. And 6 over 2, well, 6 divided by 2 is just 3. And so that's 3 right there. Cleaning up any last steps we need. And that's just going to be 3x cubed times 1, or just 3x cubed. And that's going to be that final answer. We'll take a look at one more. And this one looks kind of nasty because there's so many factors, right? Those exponents are pretty big, x to the 15th and x to the 50th. But they're really not too bad if we kind of notice the pattern of what's going on here. So I'm going to start off with rewriting the problem. Right, so the factors that I'm going to split, or the ways I'm going to split up, are right here. There's 5 over 10 to start. 5 over 10 times our x is x to the 50th over x to the 15th. Notice here, I always, if possible, want to create that giant 1. So I'm going to highlight that right here. That's what we did with this y squared over y squared and this y over y. Notice in the first example that y squared in the numerator came from y to the 6th, y to the 8th in the numerator. So there were 8 y's to play with, but if I take 2 of them out and group them up with the 2 y's in the denominator, that's what let me create that giant 1. And so if I take a look here, there's more x's in the numerator, the top of that fraction. And so I'm going to want to group up 15 x's on the bottom with 15 of the 50 x's on top. And while we're at it, let's just simplify that 5 over 10 to 1/2 times, let's see, there's 15 x's there and 15 on the bottom. Now here's the question. Well, all the x's in the denominator are right here in this highlighted piece, 15x to the 15th power right there. And we've taken 15 of them from the x to the 50th, so how many are left over? Well, let's see, if I had 50 and I took away 15, I'm left with 35 x's. And so that's going to be x to the 35 right there. This is helpful to split them up if I just notice our pattern, because I don't want to write out x, 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 and so on 50 times, and then 15 times on the bottom, and have to deal with it. Okay, and that's how we're going to group them up. Now this is helpful because this x to the 15th over x to the 15th, again, just a giant 1. And so we're left with 1/2 times 1 times x to the 35th power. We multiply all those together, we'll get, let's see, 1/2 times 1 is just 1/2 times x to the 35th, or x to the 35th over 35 over 2. So hopefully those 3 examples give you a good handle on how we can take an exponential expression. So that's just an expression with variables raised to some exponential power, or some power. For example, y to the 8th here, or something crazy like this one over here, and how we can use what we know about exponents and fractions to simplify them.